Hi, my name is Fiolka with the Atchison Planetarium and Cranbrook Institute of Science. This week, we follow on from last week's introduction to our solar system and begin the detailed phase of our tour with the arrival at the innermost planet, Mercury. You can actually see Mercury right now in our Michigan skies in the very early evening, just after sunset, low down in the west-northwest as a tiny white dot. If you were to look at it through a telescope, you'll see what looks like a tiny half moon. It's the only planet other than Venus that exhibits distinct phases because, just like Venus, it also orbits inside of the Earth's orbit. And so as a result, this allows us to see both the day and nighttime sides at the same time. But it's not visible for very long before it will dip back into the glare of the sun as seen from Earth. Sometimes, as with Venus, things can line up just right that it can even be seen against the backdrop of the sun. This magnificent event that requires extreme safety to witness since it involves the sun is called a transit. Look at that little dot seen crossing the sun's disk. Really gives us a true sense of scale. But these transits, they don't last very long, and they're actually quite rare. In fact, Mercury often seems to just come and go, with only fleeting glimpses in our sky. And it's actually what earned it the name Mercury. It's named after the Roman god of everything that requires skill, dexterity, and speed. Mercury is also revered as the messenger of the gods, again invoking images of the need for speed, conveying important messages around as only the gods would have to send. But the real reason for Mercury's apparent fleeting glimpses is its proximity to the sun. It's just 33 million miles away from the sun. Compared to Earth's 93 million miles, that's an awful lot closer. If you were standing on Mercury, the sun would actually appear 3 times larger in the sky. Being this close to the sun is partly the reason why it's actually one of the most difficult planets to study. Even the Hubble Space Telescope can't help. It's actually not allowed to look at Mercury due to the risk of damaging its sensitive components from the nearby sun. The other reason is Mercury's tiny size. At only 3,000 miles across, Mercury has the title of being the smallest planet. Our Earth dwarfs tiny Mercury. In fact, it's not even really much bigger than Earth's moon. And this proximity to the sun has also meant that it's been challenging to send spacecraft there as well. The sun's gravity and searing heat combine to try and destroy anything we send there. In fact, there have only been 2 spacecraft that have made the journey. It was Mariner 10 that gave us our first close-up views in 1974 and 1975. And then, much more recently, was Messenger, the first craft to actually orbit the planet from 2011 to 2015. The sun is not just larger in Mercury's sky, but much, much hotter too. 7 times hotter, in fact. The Mercury really climbs on Mercury to a toasty 800 degrees Fahrenheit on the daytime side. But on the nighttime side, the temperature plunges to negative 290 degrees Fahrenheit. Brr, what a dramatic temperature swing of 1100 degrees. The reason? Well, there's practically no atmosphere to help regulate the temperature on the nighttime side. And so, any heat that builds up during the day just dissipates away into space at night. But the day and night are not the same on Mercury as what we think of on Earth. Mercury has the shortest year of all and orbits the sun once every 88 days. Nice that you actually get a birthday just about every 3 months if you live there. Party time! But it rotates so slowly that one Mercurian day is actually 58 Earth days long. So one day on Mercury lasts for 2/3 of its year. And if you were there, the scorching and freezing would seem to go on for what would seem an awfully long time. And yet, even though the sun is 7 times hotter on Mercury, an astonishing discovery is that water has been found there in the form of ice. How can any water exist there, especially as ice? And that's because, unlike the Earth, that has a distinctive tilt to its axis of 23.4 degrees, Mercury sits almost upright. So there are craters in the polar regions where literally the sun doesn't shine, in perpetual darkness and unimaginable cold. So ice can exist there untouched by the heat of the sun. But how did the ice get there in the first place? Well, from comets. Yep, these solar system interlopers have been bombarding Mercury for eons of time, bringing water to the surface, which, if they so happen to land in one of these frigid areas, leaves it behind to remain there perpetually frozen. The images spacecraft have sent back reveal a surface battered by craters, and craters on top of other craters. Mercury's surface is quite dark due to the presence of carbon in the form of graphite. Yep, which is what you find in a pencil. So sometimes false color is used in images to bring out more detail, as seen here. Why all of those craters? Well, that's because there is only the thinnest of atmospheres around Mercury, which offers no protection from the relentless bombardment of asteroids, meteors, and comets. The solar system has sure not been kind to this little world. Some craters are so large that you would not even realize you were standing inside one. Look at this one, 960 miles across. Known as the Calorus Basin, you could fit the whole of Texas inside. In fact, whatever caused this impact was almost large enough to smash Mercury into pieces. The mysterious crater near the center of the basin that you can see here was initially nicknamed the Spider. But it seems that Mercury suffered an even more catastrophic impact in its early history that actually shrank the planet down from a much larger world to what we see today. This is suspected from looking at Mercury's core. Our Earth has a core too, but we've detected that Mercury's core is much larger relative to Mercury than what Earth's core is relative to Earth. How could this be for such a tiny world? Well, the answer is thought to be that an enormous fragment of the newly forming solar system, perhaps even bigger than Mercury itself, struck a glancing blow on the planet, tearing off most of the surface and leaving behind just a thin crust that still sits on the core of this once much larger planet. Where did all of Mercury's crust fragments go? It's been theorized that these volcanoids, as they've been called, are in orbit around the Sun, even closer than Mercury, but are hard to detect because of their relative tiny size next to the huge nearby Sun. Or could it be that this material became part of Venus and maybe even the Earth as well? So perhaps, if you want to look for pieces of Mercury, look no further than right under your feet. And even though the planet shrank dramatically as a result of this impact, it's still not done shrinking. No, the smallest planet is getting smaller. How do we know this? Look at these lines. They are ridges called thrust faults or scarps, and are caused by the fact that the planet is still cooling. As the interior cools, it shrinks and causes the surface to tear apart and become uneven. Some ridges are miles long, others just a few hundred feet. We see that many have not been affected by cratering, so that means they are relatively young. They're recent, and so this means the planet is still shrinking. Mercury continues to surprise us to this day with so many fascinating aspects and features. Well, I hope you enjoyed our visit to Mercury. Tune in next week as we explore Earth's twin, Venus, the Roman goddess of love. She's sure to melt your heart, all right, but she'll melt everything else too. Thanks for watching, and happy Mercury sighting in our Michigan sky.